Good morning, good afternoon, good evening, whatever the case may be. We are back in better than ever, and this is the solution for exam jam number 10. Little classical, little throwback back to the years of disco back in the 70s. This is called a fifth of Beethoven, and Beethoven was a master. You are masters at this problem, I hope. All right, so we're getting close to game time, boys and girls. A particle A is moving along a straight line. The velocity v sub a of A, t seconds after its motion, is given by such and such. T cubed minus 5t cubed plus 6t. Sketch the graph for t greater than 0 with VA on the vertical axis and T on the horizontal. Show on your sketch the local max, min, and the intercepts with the T axis. This is an absolute give me. Please tell me that it is. So here we go. What was the domain? I forget. Let me look. Does it give us a domain? Just for t greater than 0, greater than or equal to 0. Okay, so let's go ahead and set up our graph menu. Windows zoom, Windows settings. We'll go 0. I guess 10 is good. Let's go with, I don't know, pi over 2 just for kicks as our scale. This looks good. 1, and we'll go from there. All right, so now we are going to graph, let's see, x cubed, it's t, right? Minus 5t, 5x, sorry, squared, and then what? Plus 6x, boom chugga. All right, so there we go. Okay, so we can do a nice little sketch there. We have to find the maxes and the mins. What's everything that we got to do? Max, mins, and intercepts. Local max, min, and intercepts with the t-axis. Okay, so the t-intercepts, I should say. So menu, analyze graph, and we'll do minimum. Boom chugga. All right, menu, analyze graph, maximum. Boom chugga. Get that out of the way, and then we got to get the t-intercept. Menu. Analyze graph, the 0, boink, boink, okay, get that out of the way, and there we go. Oh, we got to get that other one. Menu, analyze graph, 0, over here. All right, so there we go. All right, so we got to sketch that just to cheat because I can't see them both at once, or I could, but it's just a pain. I'm going to copy it. I'm going to slap it on there, and let's sketch it. So we've got here, just make sure you do all the important parts. We're going to start at 0, 1, 2, 3. So 1, 2, 3. I guess I'll go to 5 or something. And then we have this. Where's our first 0? It's at 2, 0. And then at 3. So let's see if that's 1. This is about 1. This is 2. 2, 1. So 0.785. So that's about here. And 2.11. So that's about here or so. We'll go up a little further. Do the 3. Just don't mess this up, boys and girls. This is easy points. And then we had a min where? At 2.55. Looks like it's about halfway. And then here I'll mark -1. And so about 6, so about there. And then it just takes off. And then we do a nice, smooth little curve. And there we go. So we want to label everything, so that's 0.785, 2.11, this is 20, this is 30, and then we have our local min at 2.55, -0.631. And we have started off with a bang. Very simple, very easy. So let's get rid of that and move forward, shall we? Okay. Write down the times for which the velocity of the particle is increasing. Increasing. Well, that should be very simple. It's just the velocity. This is the graph of velocity. We found the local max and the local min, so this is where it is increasing. So for part B, it's going to be 0 less than or equal to t less than or equal to 0.785. Okay, and this is t, and this is v over here. And then also it's increasing here. So that's 2.55. Well, I guess, you know what, we can just say t, let me erase that, t greater than 2.55. We don't have to do the infinity thing if we don't want to. Greater than 2.55. Greater, you could put greater than or equal to because it starts and begins in the same spot. Doesn't matter. Either one will be good. C. Write down the times for which the magnitude of the velocity of the particle is increasing. Okay, so when is the velocity actually, or the magnitude actually increasing? Well, that occurs when the acceleration and the velocity are working together. So what we have to imagine here, remember this is the graph of velocity. So the derivative, or the derivative of velocity will give you acceleration. Okay, and the derivative gives you the slope of the tangent to the curve. So if I were to draw a tangent line, say here, yes. Okay, that is a positive slope, and the velocity is also positive. It's working together. So it's going to be increasing on this first interval is going to be the same, 0 less than or equal to t, less than or equal to 0.785. And then what else do we have? Well, so then it swings here. The velocity, now I should say the velocity is increasing. The velocity is positive, and the acceleration is positive. Here the velocity is positive, it is going down, it's still positive, but the slope of the tangent to the curve, or the acceleration, is negative, so it's working against each other, so it's decreasing. Okay, and then right here we have the velocity is negative, and if you drew a tangent line, the acceleration is also negative, so they are working together. So that's going to be another interval from 2 to 2.25 to less than t less than 2.55. And this actually matters. I messed up here. This should not be equal to, because at those points they are not working together. One of them is 0. And then the final spot would be right here. Like right here, the acceleration is positive, but velocity is still negative. And if you look here, once we get past 3, acceleration and velocity are positive because velocity, again, comes over the t-axis. So we can say t greater than 3. Very simple, very easy. Okay, lots of easy points so far. Find an expression for the particle's displacement, x sub a, from 0 at time t. Okay. Well, displacement is the integral of velocity. So that is going to be the integral, what did they call it? X sub a. So x sub a is going to equal the integral of the velocity, which is t cubed, minus 5t squared plus 6t dt. Okay, and that's going to equal, very simple, t to the 4th over 4 minus 5/3 t cubed plus 6t squared over 2, so that's plus 3t squared plus c. Okay. And we're also told right here at t equals 0 the particle is at point 0 on the line. So we know that s of 0 is equal to 0, which implies that the constant is equal to 0. So that means that x sub a finally is equal to t to the 4th over 4 minus 5/3 t cubed plus 3t squared. And that's it. Okay. And now for the last two, I'm going to go to the next page. A second particle, A, is second particle B moving along the same line has position xbm and velocity vbm meters per second and acceleration ab meters per second squared, where ab equals negative 2 vb for t greater than or equal to 0, and then they give us some parameters that we'll use in a second. All right, so what do we know? Well, we know that velocity of b is equal to the integral of the acceleration of b, which is equal to the integral of negative 2 vb dt. How do I know that? Well, they told me that ab is equal, the acceleration is equal to negative 2v, the velocity of b. So if I integrate that, I get the velocity. Okay. I also know that d, the derivative of the velocity with respect to t, is equal to negative 2 vb. Negative 2 vb, and there's no derivative there, right? Okay. So I just did this to show you the relationship, the inverse relationship between velocity and acceleration. Okay, and my task here is to find for an expression for vb in terms of t. Okay, well, how are we going to do this? Oh, I know what I want to do. I know that, what do I know? Oh, okay, I'm sorry, I got lost for a second. Algebraically, I can now write that dvb over vb, because we want to get our terms together, is equal to negative 2 dt. Not bad, not bad at all. Okay, so now I can say, if I integrate both sides, the integral of 1 over vb dvb, because I can integrate since it's the derivative with respect to v, is equal to the integral of negative 2 dt. So now what happens? Well, what is this? This is the natural log of the absolute value of vb is equal to negative 2t plus c. So now we're getting somewhere, boys and girls. Now we have a little bit of thinking to do. And using our rules of logarithms, we now know that vb is equal to e to the negative 2t plus c. Okay, and we also know, what do we also know here? That at t equals 0, vb equals negative 20. Okay, and that's not really going to help me just yet, because I need to find out what c is. So I got to do a little bit more manipulation. I know that, or I can rewrite this as vb equals e to the negative 2t times e to the c, right? And forgive me, I'm running out of room here. But isn't e to the c a constant? It's some constant, so I'm going to call it a. E to the c is some number a, because I don't know what c is, but this is some constant c. And let's go back over here. You might have said, hey, Mr. B, why didn't you add a constant here? Well, it doesn't. If I add a constant here, I could have moved it over here and combined it with the other constant. So you don't want to get a bunch of different constants going. It's just going to end up as one constant. So if you're integrating both sides of an indefinite integral, you only need one constant. Okay. So this is going to be a e to the negative 2t. Now we're getting somewhere, because I know that the velocity is negative 20 when t is equal to 0. Well, e to the 0 is equal to 1, so a is equal to negative 20. And so I finally have vb is equal to negative 20 e to the negative 2t. Booyah! All right, so we have that. And then for f, find the value of t when the two particles meet. Okay, so I'm ready for that. For f here, find the value of t when the two particles meet. Okay, well I know that x sub b, I'm going to have to integrate v of b with respect to t. See how they almost always fall back into each other? And I know that v of b is equal to negative 20 e to the negative 2t dt. Or I can integrate with respect to t. Okay, so this integral equals negative 20 times negative 1/2 e to the negative 2t plus some constant c. Okay. Time out. How did I do that? Well, you could have integrated this with u substitution if you let u equal negative 2t and then du equals negative 1/2 dt, and then you could have compensated blah blah blah. Or you could have recalled that this is a function in the form of e to the ax plus b, and the integral of e to the ax plus b dx is equal to 1 over a e to the ax plus b plus c. And that's what I did right here. So if I simplify this, I get 10e to the negative 2t plus c. And now we're going to use, what are we going to use? We're going to use this cowboy at t equals 0, x of b equals 20, right? So I know that 20 is equal to 10e to the negative 2t, 2 times 0, sorry, when t is equal 0, plus c. That looks like 20, 2 times 0. So 20 is going to equal 10 plus c. So that means c is equal to 10. So now I know that xb is equal to 10e to the negative 2t all by its lonesome, or plus 10, sorry, plus 10. Okay? And they're going to meet when x sub b equals x sub a. And we got x sub a. Where did we get x sub a? Was that on this page? Nope. We got it up here. Find a value. Oh, right here. T to the fourth. This one right here. So let me copy that. I wonder if it'll let me copy it. We're going to see here in a second. Okay. And can I highlight it and bring it? Let's see if it happens. Nope. All right, well, we have to say that I can see it at least. I'm going to set that equal. So 10e to the negative 2t plus 10 is equal to t to the fourth over 4 minus 5/3 t cubed plus 3t squared. And there's no way you should attempt to solve that by hand. So we are going to have to graph it. I thought I had the answer here. I don't. So let's go ahead and graph it. Control plus page. We're going to add a graph. And so one of my functions was 10 e to the x e to the negative 2x and plus 10, and I graph that and I don't see anything. Well, let's look at that function again, okay? Like if x is 1, t times over e to the negative 2, 10 over 8 e squared plus 10, that's going to be way up. So let's change our scale right away and do menu, window zoom, window settings. I'll leave it at negative 10 and maybe I'll go out to 20. I'm not sure what the answer is. And we'll do that too. Negative 5. And let's go 30. And we'll go 5. see if we can spot this thing. And there it is. Cool. Okay. And then we have to graph the other function, which was 1/4 t to the fourth. So we'll do 0.25 x to the fourth minus 5/3. So we're going to have fractions and decimal. X cubed. And then we have 3x squared or 3t squared plus 3x squared. Boom chugga-lugga. Isn't that beautiful? Then we'll find the intersection, menu, analyze graph, intersection, boom, boom. And there we have it, 4.41. I'm going to take a picture so I can sketch the graph nicely, because you do need to sketch the graph, remember. We're going to go back, and there it is. So find the value of t. We know that t is approximately equal to 4.41. And then we would need a little graph here. So it doesn't have to be anything fancy, just something like this. In fact, you don't have to do to the left of the y-axis, do you? Okay, and then something like this, and just this, and then 4.4110, and that's fine. And then that would do it for this problem. Boy, that was a long one, but it took a lot of explanation. Let's see how we're doing with the Fifth of Beethoven. I am out.